Hello, everyone. Welcome to Platform Conf 2024. I'm Tony from the Platform Engineering and Technology Risk Department at Ant Group. Also, I'm the founder of KusionStack, emeritus Kubernetes 6 CLI leader and creator of Kubernetes Virtual Cluster project. In this blueprint talk, I would like to deep dive into KusionStack and show you how to define internet-driven golden path with KusionStack, as well as the practice in Ant Group. Before we talk about certain tools and reference architecture, I would like to share the thinking and motivation behind KusionStack. This year will be 10th anniversary of Kubernetes, and I guess nobody would doubt the success of Kubernetes. Cloud-native technologies represented by Kubernetes already become first-party approach of so many enterprises and cloud vendors, which form a global community-driven ecosystem. And still, the continuous improvement in management, abstraction, and user experience above the Kube ecosystem is undergoing. So I think it is okay to say that cloud-native technologies are eating the world. When we look back during the journey of building our internal developer platform based on cloud-native technologies, the primary challenge comes from the collaborative configuration, just like what mentioned in Google's paper. Of all the problems we have confronted, the ones over which the most brain power and code have been spilled are related to managing configurations. The set of values supplanted to applications rather than hard-coded into them. And this problem also brings us a lot of difficulty and pain. Still, we think it's not a problem solved yet, and that's the primary motivation which leads us to build KusionStack and open source it. Except for the collaborative configuration challenge, we also faced a dilemma. For our classic DevOps platform, we met insufficient problem in openness, flexibility, and scalability, which means we did provide good developer experience for common application types, such as Java applications. But for applications based on other tech stack, like Python or Golang, the developer experience is hard to say. We tried to adopt community DevOps tools such as Helm or Customize to solve this problem. But the lack of enterprise-grade support also makes us suffer a lot. To solve this problem and challenge, we began building KusionStack since 2021 and open sourced it in 2022. KusionStack is an open tech stack to help software organizations to build a self-service internal developer platform. Just what demonstrated in this slide, KusionStack offers all the building blocks needed to build internal developer platforms. Platform teams can use these building blocks to build each layer of their internal developer platform. And these building blocks are composable and programmable, which means you can use them together as a complete IDP solution or integrate components selectively into your existing IDP while our rich APIs. Next, I will delve into the specific building blocks to show you the magic behind KusionStack. Initially, there is KCL configuration language. In classical Linux operating systems, we interact with the kernel through the shell and a variety of building tools. And the shell language greatly simplifies the kernel's programming interfaces. Kubernetes, as the standard in container management area, and has become the Linux of the cloud native computing area. The original intent behind KCL language was the wish that it could become the shell language of the cloud native area. With respect to the language design, specifically, the stability, efficiency, scalability, and overall engineering support are the core design principles of the KCL language. We wish to support infrastructure description tasks for both platform side and application side through some simple but effectively technology means. The KCL language is at the bottom of the rabbit hole. At the core of an internal developer platform, it is a platform orchestrator. That's the role what Kusion plays. Kusion enables workload central development. In other words, the application developers only need to write a single workload specification, which is based on KCL language. A workload specification defines the resources and the configurations required, but without needing to supply any environment-specific values, and Kusion will ensure it private everything needed for the workload to run. And the responsibility of platform engineering is to codify their opinions through Kusion modules, to publish these modules to OCI registry and band them to target workspace. Kusion modules, you can think of Kusion modules as bricks of golden passes. Kusion helps platform teams supercharge the self-service capabilities of their LEPs by making them dynamic, security, and inefficient. The last but not the least, Kusion can leverage Terraform to interact with existing infrastructure service of platform. Except for the Kusion platform orchestrator, we also developed a cloud-native resource delivery and operation system based on the extension mechanism of Kubernetes, named Cooperator. In terms of operation, we divide Kubernetes resources into federation and local part. The local part mainly provides resource delivery and operation within a single cluster, such as computing and networking capabilities. In the federation part, Cooperator offers cross-cluster resource delivery capabilities through our self-developed federation controller runtime, such as progress delivery of across cluster applications, the unified gateway of cross-cluster applications. In the operational aspects, we have implemented an automated delivery process with the risk control in the controllers behind the declarative APIs to balance the efficiency and risk. For instance, change to Kubernetes ports, Kubernetes Cooperator extends the native Kubernetes to include pod ops lifecycle management. It helps users integrate more pod-bound operation tasks like traffic rerouting before and after change, and risk presentation capabilities such as change watermark protection into the pod change process, making them part of the automated operations. Change with confidence is the key to success. Without deep insight, you cannot get any confidence. KusionStack Explorer adds advanced search, insight, and intelligence to your internal developer platform. With KusionStack Explorer, you can ask any questions about your application's workload-dependent resources across any clusters, any cloud using either structured search queries or natural language prompt. Search helps you find detailed info of single resource, as well as running complicated queries such as tracking down orphan resource across the whole cluster. Also, you can get deeper insight into your application, such as resource cost, security, and compliance concerns, as well as the relationship between different resource types. All this can give you more confidence to do application change. The last part, we will refer to the server side of the Shakespeare service. Our service represented in this slide to help show the ideas behind KusionStack. This service is a simplified web app made of a battery running in two classes for the high availability, implementing the front-end logic and load balancing with both a per cluster and a global configuration, as well as a global database for storage. For developers of Shakespeare service, the most important thing is they can self-service with no waiting times due to ticket ops. To enhance self-service capability, platform engineers must provide corresponding intent-driven golden paths. Based on KusionStack, it will be quite easy to define such intent-driven golden paths. From the perspective of service developers, they only need to describe their intent with kinds of workload, accessory schemas, as well as specify the deploy context, which points to the target cluster. From the perspective of platform engineers, they lead to develop necessary Kusion modules, such as the workload modules, the network modules, and the database modules. Also, those modules must be published to OCI registry and then collected to target workspace, which means they can only be used in this workspace. With all these intent and module definitions, Cushing Stack knows how to generate file configurations and resources. And in the cluster side, the Cushing operators will reconcile to match developers' intent. So that's just how we can define the intent-driven golden path with Cushing Stack. That would be quite easy, right? Still, I would like to share some data about the practice in Ant Group. We have published 100 Cushion modules so far, almost cover all the infrastructure providers and runtime capabilities. Those modules have been used by 1,500 developers and 3,000 applications, which brings significant impact on the productivity of development. All right, we have come to the final part of this talk. We have already partially open sourced our platform tools, and in the future, we plan to open source more platform capabilities and just welcome everyone to join our community. So, thank you all.